Hello everyone, welcome back to Math 0332. Today we're moving on to Unit 2 and we're starting with, it's a kind of a shorter unit, we're starting with evaluating algebraic expressions. So you'll probably see these on the homework. There's not too many of them, but they could be one or two variables, and it's primarily about understanding what it is asking you to do. So when you're evaluating expressions at a given value, you're really replacing the variable in the expression with a given value that they are stating. For example, if it says evaluate the given equation x plus 5 at 9, you see x is equal to 9, which means you're going to replace the x in this expression with 9. So instead of x plus 5, it's now 9 plus 5. And by doing so, this should allow you to evaluate it and get an actual answer. Since 9 plus 5 is 14, this is 14. Now this could also happen with multiple variables. For example, 2L plus 2W, which is the formula for the area of a perimeter of a rectangle. They could ask you to replace both the L and W with the values, so it will go very similarly. Replacing L with 4. I like to sometimes put the variable I'm replacing something with in parentheses to let me know that that's what I've done. Replaced the L with 4 and the W with 7, and then we use order of operations to simplify. 2 times 4 is 8, 2 times 7 is 14. There's still a plus between them because multiplication will come first, and then 8 plus 14 is 22. Looking at number 3. 3x squared plus 2y squared minus xy. Again, it's 2, and here there are multiple things. One thing to note, again, is that your order of operations are important. So everywhere that I see an x, I'm going to replace it with a 2, and everywhere I see a y, I'm going to replace it with a negative 1. So this is 3 times, in parentheses, 2 squared, plus 2 times, in parentheses, negative 1 squared, then minus, I'm going to put both parentheses here, 2 times negative 1. Using our order of operations, there's nothing inside parentheses to fix, so our exponents are next. One thing that people will often do going left to right is they'll do this 3 times 2 first. Do not do that, that will give you the wrong answer. This 2 needs to be squared before it's multiplied because exponents come before multiplication. So 2 squared is 4. Negative 1 squared, which is negative 1 times negative 1, is 1, and we're going to leave everything else alone. Now, 3 times 4 is 12. 2 times 1 is 2. Here, 2 times negative 1 is really negative 2. So it's 12 plus 2 minus a negative 2. This is all addition and subtraction, so you go left to right. So this is 14 minus negative 2. If you are more comfortable with distributing the negative, so that this is really 14 plus 2, that works as well. But either way, you should get 16. And I'll leave number 4 for you to do. One thing to note is that when you plug in x and y, remember big division bars is like the whole thing's in parentheses, so you're going to add or subtract before you do any of your big division if you are working on that problem. Now sometimes though, when you have expressions like this, they're not going to ask you to plug in values, they're going to ask you to simplify them, which means combining your like terms. So when you're simplifying algebraic expressions, remember that those letters just represent numbers, but I like to tell my students sometimes you can think of a variable like a cookie. You've got 8 cookies and you're subtracting 7 cookies, well then you know how to answer that question. What we call those is they are the same variable with the same exponent. They are called like terms, and you will add or subtract their coefficients together. But sometimes variables like down here are the same variable, but they're not the same exponent. So if they're not the same exponent, then you cannot combine them together. It's like a cookie and a brownie. You're not going to combine your cookies and brownies together. No matter what anyone tells you about brookies, you go in knowing ahead of time you're making them. You don't suddenly smash a cookie and a brownie together and, you know, it's magically something new. So simplify the algebraic expressions. When they do have the same variable and exponent, they can be combined in a similar way as we did with the square roots in Unit 1, where you look at the coefficients in front of them and you combine those together. So 8b minus 7b is really 8 minus 7 total number of b's, well, which is just one b, which you may also write as b. So that leads us to another part of the discussion where we talk about if there's no exponent there, the exponent is a 1. Similarly, if there's no coefficient there, it's also a 1. Number 2, 7y plus 3 plus 6y. Again, there's a few different ways you could do this. I like to notice that 3 and 6y will not combine in here because they're not, one is a variable, one doesn't. So the parentheses really isn't needed at all. However, one thing that I like to do when I'm combining multiple terms is I like to underline the ones that are the same and combine them before I move on to the other ones. So 7y and 6y are the same, so I'll add my 7 plus 6, which is 13y together. The 3 doesn't combine with those two. It's on its own, so I would probably just bring it down. If there's nothing to combine it with, you just bring it down to the next line. Number 3, x squared plus 3x plus 4 plus 11 minus 7x. Again, I like to start one thing at a time, and if it doesn't combine with anything, bring it down. This is the only x squared in the whole problem. Looking at my next things with variables, we have a 3x and a negative 7x. When I add 3 and negative 7, I get negative 4, and you keep whatever variable is attached to it. 3 cookies, take away 7 cookies. I owe someone 4 cookies now. And then finally, 4 and 11 are both constants, so we combine 4 plus 11 to get 15. Now, sometimes you also, though, have to distribute, get things out of their parentheses before you can combine. So when you see a number and then multiple terms and a parentheses after it, go ahead and distribute. 2 times 6a is 12a. 2 times negative 3b is minus 6b. Similarly over here, 5 times 4b plus a. 5 times 4b is 20b. 5 times a is plus 5a. That means all of my a's and all of my b's are going to need to be combined together. So looking at my a's, we've got 12a plus 5a is 17a. Negative 6b plus 20b, so 20 minus 6 is 14b. And that covers most of the first and second homework in this unit. It'll come back into play in the third homework as well, and we'll take a look at that in the next video.